Good morning, dear student. Myself Amit Kumar Singh. Today we will discuss the heap shot algorithm. So, before the algorithm discussion, we will discuss about the heap shot and how to understand what is the heap shot and what is the heap. That is a heap. We have defining the heap. A heap is the data structure that stores the collection of object and has the following property. That means the heap, that is also called the binary heap. It is the data structure and its collection of the elements in the tree format, and this format is belongs to the heap ordered and the complete binary tree. Basically, algorithm have two major steps. First step, it is involves the transforming the complete tree into a heap, and the second major step is perform the actual sort by the extracting the largest and lowest element from the root and transforming the remaining tree into the heap. We will discuss at the another type. That means heap sort algorithm can divide into two parts. In the first step, a heap is built out. That means we have built the heap tree. Okay, the heap is often placed in an array with the layout of the complete binary tree. ठीक है ना? Okay, and the complete binary tree map the binary tree structure into array indices. Okay, first we have to construct a binary is complete binary tree, and this complete binary tree is structured in the array as one by one, and each array represent a node. Okay, this is right. The index of node parent, left child of branch, and right child of branch are simple expression. Okay, and the property is discussed further and in next, and in the second step, it is it load array is created by repeated removing the largest element from the, that means that is called the extraction of the value in a heap, resulting in the after extract largest value of the element of the heap, extracting and insert into the array, and heap is updated after removing maintain the heap property. That means first value is extract, then overall tree is behave like a heap tree. Okay, that means he is maintaining the heapify conditions. Okay, so we will discuss in algorithm and other types. So this type two type of step we will follow in the heap. So first we have construct a heap using the complete binary and some heapify performance, and extracting as follow. At the heap, at the as a max heap, we have extract the largest value of the element, largest tree value, and after extracting and putting this value in an array, we have follow the heapify and maintain the heap property. Okay, so here we will discuss two type of heap. Heap have two types. One is called heap and next one is called min heap. We will understand what is the min heap, what is the max heap through the given example. Here we have to construct a max heap example. That means in this max, every node is greater than his child, and child. Okay, that means you have to see 19 have two childs, this is 12, and both are less from its parent. Okay, and then 12 is parent of 1 and 4, then 12 is greater than 1 and 4 both, and 16 is the parent of 7, so 16 is greater. And this is the max heap example. Okay, if this heap tree is inserting in the array, then continuous indices follow this is 19, 12, 16, 1, 4, 7. That is, this is the max heap in the array. Okay, and next example is min heap. Okay, so in the min heap, the root, that means parent node is less than the child node. Okay, that means here we have to see one have two childs, 4 and 16. That means one is lesser than the 4 and 16, and when 4 is as a parent, then child is greater than 4, that is 7 and 12. And then same condition here, 16 is a parental node, then child 19 is greater than parent. That means in this condition, the parent node is greater than or equal to, sometime we have say or equal to your child. Okay, and array representation, sequentially we have to fill the array from level 0 to level next 1, 4, 16, 7, 12, 19. This is array representation. And we have defined what is the max, what is the min. Then here it is also definition. What is the max heap? Max heap is a complete binary tree in which value in each internal load, value is each internal load greater than or equal to the value of child of the node. Same we have to see here. Okay, here the child is always less than or equal to parent. Then same discussion is here. It is complete binary tree, it is follow the complete binary tree. I hope you have understand the complete binary tree. And okay, and all the internal load, external load, that means he will say sometime the node is, or sometime node is root node. So root is also parent, and internal nodes are also as a parent, but it is always greater than or equal to its child. That we have to call this type of complete binary tree, that is a max heap. Okay, and this is a property of max heap. The key of node is greater than or equal to key of its child. So this point is discussed by me. So the next point is that uh, how to operate on the max heap. So first of all, for operation, we have to know a given array. If we have a given array and we have construct a max heap, then how it can be possible? And that means is there 16, 14 array is there above, 16, 14, 10, 8, 7, 9, 3, 2, 4. This is already in the math. Then how you know who is the child, who is the parent? Then we will start the root tree is a of I. This is first we have to root, consider in root. And how to know this is left child, how to know this is right child? After finding in the middle, how to know it is a parent? Okay, so if you have to consider a of I equal to 2 times of I, then this is left child of the root. uh, uh, for example, 16. Okay, 16 is the index number 1. Okay, then put it value I equal to 1, a of I, this is 16, equal to a of 2i, this is 2 times of I, that's 1 into 2 is equal to 2. That means a2 value is the left child of 16. This is okay. a2, this is 14. 14 is the second position, and if you are finding the right child, then you have to apply a of I equal to a of 2i plus 1. Then we will check one example. uh, for first end is equal to 1, then a of 1, that is 16. For 16, what is the right child? Then 16, 2 into 1 plus 1, this is third. The third index value is right child of the 16. Okay, and if we have to want the value 9, index number 6, you see clearly. Okay, index number 6, value is 9. uh, we have to consider finding the parent of 9. Okay, then how to find the a of I, and this is 6. That is a of I equal to a of uh, a of I divided by 2 using the floor function. Okay, then why I hope you have understand what is the floor and what is the ceiling function. Ceiling, that means if are the given values fraction value, then we have to consider the value above, and if I have a floor function, then we have a lower, consider a lower value. I is 6, 6 divided by 3, that means third position is uh, parent of 9, this is 10. You have to see in a tree, this is okay. This is the operation on the heap operation. Okay, and okay, example explaining here. Given a array a equal to 4, 1, 3, 2, 16, 9, 10, 14, 8, 7. I hope I is started with the 5. Okay, and if I is 5, okay, then fifth index value is if you have to consider fifth index value is this one is 0, 1, 2, 3, this is I equal to 5, that means fifth position of the element here. This one is, sorry, this is fifth, this is red circle, and the fifth node value, that is 4, 1, 3, and 2, and fifth is as a 16. Okay, then put it here 16, and what is the fourth index value? Then put fourth index value 4, 1, 3, 2, this is 2. Okay, and I equal to third position pair, that is third as a parental node, then put it third value is 3, and then I equal to 2, and if we will put 2, and second position is 1. Okay, and second position is 1, and first position is as a 4. Okay, and after that we have to heapify this value, and we will discuss in next slides. Okay, so build a max heap. How to create a max heap? If you have given this tree, and how to max heap create, then we have to discuss algo as a max heap in later, after discussing the this example. Example array value is 16, 4, 10, 14, 7, 9, 3, 2, 8, 1, and we have put one by one left to right filling the node. Then 16, 4, 1, yeah, oh sorry, 16, 4, this is 10, this is not 1, 1 and 0 up and down, and then 14, 7, 9, 3, 2, 8, and 1, this is filling. And he say you have construct a max heap. Then in a max heap we will know the parent is always greater than our child, but here have some problem. Parent just like a 4, 4 in a node 16, left first value, this is 4. He is a parent node, but his child 14 is greater than, 7 is greater than, and same condition, no other same here occurred. So one thing, this is 4, then we will discuss. And 4, here 4 is uh, our parent node, which is lesser than 14 and 7 both. Then he checked the a for 14 is greater. Okay, first he checked left side and or right side, then 14 is greater. But after checking 14 is greater than 4, then he will not swap easily. He is discussing with the 7 also. Okay, and then after that he will swap, that is 14 is go on 4th position and 4 values are on the 14th position. Then find this type of array. Okay, and 16, 14, 10, 4, 7, 9 and so on. This is max heap 5. Okay, and after that we will after that we see here one thing. 14 is at the place, but 4 is at the left side of the 14. But 4 is 4 is again as a parent node, and it have 2 and 8, two childs. But 8 is greater than 4. But in we know that in a max heap no parent is less than our child. Okay, अपने child से छोटा नहीं होना चाहिए, that not less the child, it is equal to or greater the greater value from child. Okay, so my heapify is again process. 4 is taken here, then check the left, this is lesser, and check the right, this is 8, and then position of 8 is to each other and heapify it. Okay, this is the final 16, 14, 8, 10, 8, 7, 9 and 3, 2 and 4 and so on. Okay, that means 4 is always check. Next time we will check, then it have no leaf, it have no child, though says this is successfully you have to heapify as a vaccine. So what is the sorting strategy in the heap sort? If you build a max heap, then what you do, the first max build the max heap from unsorted array. This is okay. That means he will say, if a given array, then you have to create a max heap unsorted array. Okay, that means you have sorting is another process. You have to construct a max heap. Okay, using the 5. Okay, and second, find the maximum element of array 1. Okay, that means find the maximum element. You have to find the maximum element in a max heap. The root node is the maximum element. Okay, this is okay. Because of that we have to discuss max heap and find the maximum element. Then maximum element in the root is, then we will swap the element of an of a1. That means first element is swapped with the last element. Okay, and now after swapping, the last element have is your largest value, and you have to cut from end. Okay, आप क्या करेंगे, now the max element at the end of array. Okay, and store in a array, and discard node n in the heap. Okay, and decrease the size of heap. Because of that, the last node which is our greater value, which we have to store in our array. Okay, and new root are volatile max heap property. That means we have to check after swapping, as a root node is follow the max heap property or not. If it is not, then you have to max heapify, otherwise go for next. Okay, that is okay. And it is going at the end of position, position when the heap is not empty. Okay, here we will discuss about the max heap: 16, 14, 10, 8, 7, 9, 3, 2. This is the max heap. It is completely we have to discuss. This is max heap heapify. Then first what we will do, and first we will do the greater element is goes on the last index number. ठीक है ना, that is this one is 10. Okay, and the last value is swapping from this here, that it is this one. Okay, and after that he 16 is here and 16 is stored in the array, and we have to consider this is cut it from the field. Okay, okay, so next again, uh, okay, done. So here same procedure, one is there, one is here the value 16 is there, and here after heapify this is 14. Okay, after heapify the uh, middle heapify step are skip here, and 16 is stored in our array, and 14 is a new root node, and after that 14 is extract from here, and last one is further position of 14, and then one is less value between the 8 and 10. Okay, left and right child. So max heapify is again procedure. So next step 14 is here and 10 is root, and so this is the process of extracting. Listen carefully one thing again. First, if you have to find a max heap, then you have your maximum value replaced with your uh, highest index value number. After that you have extract the last value which is greater, and store in an array, in array index last index number, and then you're finding your tree and check this tree is max heap or not. If it is not, then you have max heapify, and then further go for next extracting the value, and then 14 is extract here, and next 10 is extract here, and next one is 9 is extract here. After that 9 is extracting, 8 is extract here. Same procedure, follow the same conditions. We have we have extract our root, and and last index value is set as a root, and then max heapified, and after heapifying max heapify, we will find the new heap tree, and then follow the same rule, and after 8 the 7 is follow here, and after 7 we will find 4 is there, and after 4 we will find 3, and then 2, and then 1, and this is the max heap procedure, how to extract from the max heapify. Okay, that means before that means one thing you have to know: first you have to construct a heap, and then after constructing heap tree you have heapify. You have heapify in the max heap or min heap, as you know. After that, if you are going for the sorting of this heapify tree, then you have extract the if your heap is max heap, then you have extract the greater value which is root, sending to the last index number, and last index sending to the root, and then last index value is storing in the array, and then heapify your tree, and further again and again after. um, so we will discuss the next heap sort pseudocode. It is a simple, this is same which we will discuss. Heap sort a as a array we will know, and build the heap. First we have to build the heap and then follow the for loop a of n to 1, and this is simple, and swapping these values, and then first check the heapify, and then again we will build the your heap. So at the next, how to heapify. This is the procedure of heapify, and first of all, first you have to consider how to heapify. So the procedure of heapify, okay, we will understand what is heapify and how to work heapify, and I hope you have to understand. Heapify, no, left side, this is algorithm. A as a array, that means if we give an array, and I is the integer value where we have to perform the heapify. I is where you have to perform your heapify. That if you have to consider, this is array 50, and this value is 15, this is 6, this is 4, and this is some one value which are less than 4, and this is 8, this is 5, this is 2, this is 7, and where we have to need heapify. First we have to check here, this is okay because 8 is greater than 2 and 7 both. And next one is here 4. I have to say there is 3, there is 1, you have to consider to assume that. And then we go for 6. 6 have 8 and 5. The 5 is okay, but 8 is not. With that we have to know, you have max heapify, then 8 is not a child of 6. Okay, so how to heapify? Then we consider a of 2, that is a array of second position here. That means this is first position, this is second position, this one is third position. Okay, this is position. Okay, then you have to check the left and right. Okay, then left is equal to 2 of I is the 2, this is fourth, this is 4, this is fifth position. Okay, this is 4. Okay, this is left is fourth position, and this is right is 2 into 2, this is 4 plus 1, this is fifth position is right. Okay, if left is less than or equal to n. Okay, and that means you have to say heap size. Okay, heap size is total, we have to know, this is 1 2 3 4 5 6 7 8 9 elements are there. Okay, then a of array of this value is 9. Okay, and first left, that means left, this is fourth, then fourth value is 8, this is 8 here, 8. Okay, 8 is less than or equal to n, and that is here we have to check a heap size. Okay, we have to check heap size, this is 9. Then it is less than or equal to 9, yes, this is right. And if a of left, that means a of left, this is 8, is greater than the a of I, and then I is this is 2, and a of 2, this is equal to 6, this is also okay. Then max is left. Okay, max is left, that means they have to swap these values. Okay, that means one condition to heapify. Okay, and next one is we have to check, otherwise we have else and condition, and if the first condition is not true, then we will go for the right side of the child, that means both side of we will check. Okay, and this is the procedure to heapify your okay. So next one is min heap we have discussed if the parent is less than child, that means a parent is less than or child values, this is the min heap. And there is a definition. The min heap definition is complete by it is a complete binary is the value of each internal node lower than or equal to value in the child of that node. Okay, this is and this is a property of the min heap. Here we have to write the key of node is less than or equal to key of the child. This is okay. And same thing is follow is here operation where the root is on the 0th position, then the formula left child. We will want to left child in a min heap, then we have to apply the formula a of 2i plus 1, this is left child. And if you want to the right child, then you have to plus 1 and another, then that means the formula a of I is 2 of I plus 2. And if you want the given array and find the your parent in a min heap, then you have to apply array of I divided by 2, that means the index number is divided by 2 and minus 1, then we will go for a root of the child in a min heap. Okay, this is the sum operation in the min heap. So we will discuss here min heap. First here we will check this is min heap 19 12 and 16 1 4 7. Can you say this is min? What is the property of the min heap? uh, we have discussed min heap is the have property which parent is minimum or equal to the value of a child, but here parent is 19 and child are 12 and 16, this is not, and 12 is and okay. So we will go for the min heap. Then first what to do, then first what to do, first you have to check from here. Okay, and this one is here. First we will start if we will one is 16 and 12, this is greater than this one, this is not min heap. In the min heap parent is less, so first of all he check one, this is swapping these values. Okay, and we will go, this is 1, and after that we will discuss lesser than, then we have to 1 is lesser in 19, then they shifted to there, and after that shifting 1 we will see here 19 is greater than for both. Okay, and in min heap it is not right. Okay, so and 16 is place with this one is 16 and 7 also exchange, but here one problem again, then again apply the min heap and finding the exact position of 19, then this is 12 and this is 4, but 4 is more lesser than values of the 12, then 19 is shifted to the 4 and we will find here. Okay, this is the min heap. And how to extract the min heap? Okay, if we have to want the extracting the min heap, then you have to here 1. Okay, this is set, this is swapping with the last index value and goes for this is 16 and 4 and 7 and 12 and 19, and here is 1. Okay, and then 1 is stored in a array. Okay, and then cut it here, and then again min heap heapify here. Okay, min heap apply. Okay, so same procedure is follow, one is there, and next one next step you have to see next step. This is 16 is goes on there. Okay, after second position we have to heapify, and after heapify then is lower position at this. So next one is 4 is upper, and 16 is greater than 12, then next heapify, then 16 goes at the place of 12, and 12 goes to the place of 16. This is right. Okay, and then at the 4, and after accepting the 4, that means 4 at the 4 position at the 19, and 19 goes to the 4. Okay, and then 4 store in your array. This is right. Okay, so next is this. Okay, 19, 12, 7 and 16, and check is the parent, and this is less than 16. 19 is the also parent, but greater than 12 and 7, but 7 is lesser than position of 7 is upper, and 19 is at the position of 7. This is right. Okay, and this is min heap, so we have to extract 7, then element is stored in your 7, and 16 at the position of 7. So this one is 16, 12, 19, but 16 is greater, then heapify is apply here. Which heapify? This is min heapify. Then 12 is on the position of 16, and 16 is goes on this, and then extract the 12. After extracting the 12, the position goes to 19. 19 is above and 16 is there. ठीक? And again we have to apply the min heapify. Okay, we have apply, that means 19 is greater, then first you have to swap these values. Okay, 16 and 19, and 16 is then extract, and last one is 19. That means we have to extracting all the values at the sequence of 1, 4, 7, 12, 16 and 19, and then finally we have to sort this element. That means in a heap sort, first we have to construct a heap, and after constructing a heap we have to go as a heapify. You have to go as a max heap or min heap. After constructing the after construction the min heap or max heap, you have extract the value at that type of algo apply. Okay, and what is the insertion about element in a max heap or min heap? So at the element, overall I will tell you, uh, i i I have to tell you, in this insertion, after inserting the element in a heap tree, you on heapify. That means he maintain the property of heap. That is okay, and same thing is right here. That means algorithm add the new element to the next available position at the lowest level. Second, restore the max heap property if volatile. General strategy is pre up and bubble up. Okay, if the parent is of the smaller, and then interchange the values, restore the min heap or min heap. General strategy of pre correlated by the if the parent is larger than the element, then inter parent child is the same. I will take an example. Okay, this is your first tree, 19, 12, 1, 4, 7. This is your given tree, and you have to insert a 17. Then your desired position is next position is 16, right child of is 17. But if it is a max, you have to check this uh, inserting the 17, it is follow the max heap property or not. Okay, first of all you have to check easily that property is follow or not. And 17 parent of 17 is 16. 16 is less than 17, but it is the max heap, so we will swap the values and uh, uh, extract the as a maintain the heapify max heapify property, and then follow this overall max heapify and find the insertion. Okay, and overall max heap will be storing as a primary advantage of max heap is efficient and execution time is big old log, and we will discuss in next video lecture. And the memory efficient in the heap sort, unlike other, and log and shortage, and this one is, and this is conclusion. That means heap sort is a more efficient than previous short like bubble insertion and selection. So we have to discuss the analysis of heap